The Milky Way is immersed in a gigantic pancake of dark matter.
Astronomers have discovered something fascinating about our place in the universe. The Milky Way doesn't simply float in a vast, isolated cosmic void.
In fact, our galaxy is completely enveloped by a huge, flattened structure of dark matter, resembling a giant pancake, and we are like a tiny blueberry inside it. This revelation came from a team led by astronomer Ewoud Wempe of the University of Groningen in the Netherlands. They used highly detailed computer simulations of the early universe, based on data from the cosmic microwave background, the oldest light we can observe, and compared the results with the actual movements of nearby galaxies. By analyzing how 31 isolated galaxies move in the space around us, the researchers were able to accurately recreate the speeds of the Milky Way and the Andromeda galaxy. The only configuration that worked perfectly in the simulations was one in which dark matter, that invisible mass that neither emits nor reflects light, is concentrated in a kind of flattened sheet or disk. This pancake has a density that increases as it moves away from our local group, the small set of galaxies where we are, and leaves large, deep voids above and below this plane.
This structure explains three strange characteristics of our little piece of the universe that have intrigued scientists for years: the local sheet, an almost flat arrangement of galaxies where our local group is located; the local void, a gigantic region almost devoid of galaxies right next to it; the so-called quiet Hubble flow, that is, the expansion of the universe happens in a surprisingly smooth and calm way right here near us, without major gravitational disturbances. Previous models had difficulty explaining these points simultaneously, especially because the combined mass of the Milky Way and Andromeda seemed insufficient to justify the observed calm. Now, with the sheet-shaped geometry, everything fits. Gravitational attraction pulls matter sideways, creating the void above and below, while the flat configuration reduces the inward pull, allowing for a smoother expansion flow.
The most interesting thing is that this discovery doesn't require any new or exotic physics. Sheets and flat structures of dark matter are already predicted by the standard cosmological model, called lambda CDM. What the research shows is that, in our specific case, the local environment formed exactly this way, as Ewoud Wempe summarized. They are exploring all possible configurations of the primordial universe that could have led to the local group we know today, and now they have a model that perfectly matches what cosmology predicts and what we observe in our cosmic neighborhood. This new perspective helps us better understand how galaxies form and organize themselves within the immense cosmic web, and reinforces the idea that dark matter, even though invisible, actively shapes the architecture of the universe, including our little corner of it.